Hello everyone, welcome to my YouTube channel TechSpot. This is me Harish Goupale. So basically in this video we are going to discuss about what are the system Verilog and Verilog data types, and also we are going to discuss about what are the different format specifiers are available in the system Verilog. But before going to start the video, I'll request you, if you are new to this YouTube channel, then please subscribe to my YouTube channel. So let's get start with the basic understanding of data types. So basically in system Verilog or in Verilog, we are having two types of data types. One is two-state data types, and another is four-state data types. Two-state data types means it is having two possibilities, either 0 or 1. And similarly in four-state data types, we are having four possibilities, either 0 or 1 or X or Z. X means unknown value, and Z means high impedance. Okay, now let's jump to understand what are the two state data types available in system Verilog and in Verilog. So the first two state data type is real. Basically, real data types belongs to the Verilog language, and it's a 64 bit signed data type. Signed data type means it is having a range from negative value to 0 to positive value. Okay, now the next data type is short real. Basically, short real data types belongs to system Verilog language, and it's a 32 bit. Name suggests if real is the real data type is 64 bit width, so the short real width has 32 bit, and it is also a signed data type. Now the next data type is bit. So bit is also belongs to system Verilog language, and its width is 1 bit. And as bit is 1 bit, so possibilities can be 0 or 1 only. So that is the reason it is unsigned data type. Okay. Now the next data type is byte. So byte also belongs to system Verilog language, and its width is 8 bit, and it's a signed data type. Okay, now the short int. Basically short int also belongs to the system Verilog language, and its width is 16 bit, and it's a signed data type. And after that int, if short int is 16 bit, then obviously int will be 32 bit width, and it is also a signed data type. And then long int, both of three data types belong to system Verilog language. Only the difference is short int has width 16 bit, int has width 32 bit, and long int has width 64 bit, and all three data types belongs to signed data type. Now we'll jump to understand what are the four state data types available in system Verilog or in Verilog. So the first is range. Basically, range data types belongs to Verilog language, and its width is 1 bit only, and it is unsigned. Unsigned means what? Either possibility 0 or 1 only. Okay. After that, wire. Basically, wire also belongs to Verilog language. Its width is also 1 bit, and it is unsigned. If I talk about the difference between range and wire, so basically range is a storage data type, and wire is a net data type, which is used to connect two elements only. Okay, and by default value of range is unknown, and by default value of wire is high impedance. Okay, now next is integer data type. So basically integer data type is also belongs to the Verilog language, and its width is 32 bit, and it is signed data type. Obviously width is more than 1 bit, then the data type is signed type only. Now the time. So time data type also belongs to the Verilog language only, and its width is 64 bits, and it is unsigned, as time represents time only. So we know that time can't be a negative value, so that is the reason time is unsigned data type. So it is having range from 0 to positive value only. Now the next data type is logic. Only the logic data type, only the logic is the four-state data type, which is belongs to system Verilog language. Its width is 1 bit, and it is unsigned type. Now we'll jump to understand what are the format specifiers available in system Verilog, or we can say in Verilog. So the first is %d. %d basically used to represent decimal format. Okay, we can use %d to display decimal numbers, and after that %b, obviously b suggests binary values. So %b is used to display the binary number, so it represents binary format. Then after that %o. So %o is used to represent octal format. We can display octal number. Similarly, with percentage, we can display hexadecimal values, and after that, we have percent %c. So basically, percent %c is used to represent ASCII numbers. We can easily display ASCII characters by using percent %c. After that, percent %t, it is just time, so it is used to represent time. We can display time by using format specifier percent %t. After that, percent %s, it is used to represent a string, so we can display any names by using percentage. After that, percent f, so percent f is used to display the real values, and it represents real exponential in format. After that, percent t, so percent t is used to represent real in decimal formats. So these all are about the format specifiers. Okay, now we'll jump to implement all the data types and format specifier on a EDA playground to see the default data types of default values of all the data types and use of format specifier. So here on my screen, you can see I have already write a code to display the default values of all the data types. Here you can see I have taken all the data types. So these are the two-state data types: real, short real, beat, byte, short int, long int. Some of the data types from Verilog, some of the data types from Systemverilog. These are the four state data types: range, wire, integer, time, logic. Okay. This is the first initial begin. Inside the first initial begin, I have written a display default value of real, short real, beat, byte, short int, long int, range, wire. So this display will display the default values. After that, here in second initial begin, what I did, I have given dollar random to some of the data types to see the use of format specifier. Like here I have used format specifier percent t, percent f, percent c, percent d, percent o. Percent o is used to represent octal value. Percentage is represent hexadecimal value. Percent t is used to represent the real value in the decimal format. Percent f is used to represent real value in exponential format. Okay, so now we'll I will click on this run button and we'll see the display what are the default values of all the data types, as well as the um, you what format specifier, what value will give format specifiers. Okay, that will see. So here you can see the default value of real in decimal format is 0. Default value of real is 0. Default value of short real is also 0. The difference is real belongs to the Verilog language, whereas short real is belongs to system Verilog language. Now, default value of bit is 0. Default value of byte is also 0. Default value of short int is also 0. Default value of int is also 0, and default value of long int is 0. That means if the data type is two-state data type, so the default value will be 0. Now four-state data type, the first is range. So basic here range is four-state data type, and the default value is x. Similarly, default value of wire is z. As I already told you, the difference between range and wire. Range is a storage element. That is the reason x is unknown. By default value of x is unknown, and wire is a net data type. It is used to simply connect two variables or two elements. That is the reason the default value of wire is high impedance. Now default value of integer is x. Default value of time is 0, because time is a unsigned data type. So that is the reason default value of time is 0. Default value of logic is unknown only. Now value of real in decimal format, here you can see it is in the decimal format. Value of short real in exponential format, it shows the display. Value of byte in ASCII format is 8. Actually I have given some another value. Here you can see I have given 56 value. So in 56, uh, in the ASCII format, 56 is represented by 8, so it represents 8. By using percent by using format specifier percent %c I have used. That is the reason it has given ASCII value. Value of short int in decimal is this. This is given by negative value. Value of octal format, and the value of long int in hexadecimal format. So we'll stop here in this video. What I have explained, I have explained all the data types, basic data types of Verilog, system Verilog, their default values. Also I have explained about format specifier. So if you are watching this video, then please like the video, also subscribe my YouTube channel and press bell icon for the more videos for the notification also. So here I will stop the video. Thank you so much.